Hello guys, hope all of you are doing great. In this part of the video, we'll be learning about infinite loops. Infinite loops are not some mistakes that you should avoid doing. Rather, in this part of the video, we'll be learning how important the concepts of infinite loops are to solve some practical problems. By the end of this video, we'll be developing a small game. Don't worry, it will not be a very complicated one, but while doing so, while developing that game, we'll be learning the importance of an infinite loop to solve such a problem. And also, while learning about these infinite loops, we will be learning about a very useful concept in Python. Not only in Python, basically it is there in all the other programming languages, and that concept is about a break statement. We'll be learning about break statement in this video only. And also, while developing that game, we will be playing a bit around with random numbers. So all these we are going to do in this part of the video. So fasten your belt and let's begin. Okay, now let's see what is an infinite loop, right? A loop, the name itself indicates a loop that goes forever. It's an infinite loop. Let's see how we can write an infinite loop using, say, while loop. Okay, we can write it using for loop and while loop. Let's see how to do it using while loop and for loop, and then we'll get into the details of the things. Okay, let's start with this while loop, while infinite loop. Okay, so say we have a variable I, and I initialize it to 0, and then I write something like while I write here a condition that which is always true. Okay, and say for example I write here I is less than 4, and then here I write print say something. I write here, say maybe hello. Now what this program is doing is now I can execute this program. This is a complete program. Now if I execute this program, then what will happen is initially the value of I is equal to 0. It is checking whether 0 is less than 4 or not. 0 is less than 4, true condition, so it will print hello. And after printing or after executing the body of the loop, what it will do, we know that the control will go back here and it will check the condition one more time. Now, since we didn't change the value of I anywhere, so the value of I is still 0, and 0 is less than 4, it will be true again, obviously, isn't it? So, as you can guess now, what will happen is if I execute this program, again and again this condition will be true, and then again and again it will be printing hello on the screen. There is a spelling mistake here, I guess, HELLOW. But anyhow, let's execute this program and check the output here. See, if I execute this program, it is just going on printing HELLOW or whatever I wrote actually. Don't worry about this spelling, right? So it is an infinite loop, right? Now here at this point, it might seem like, okay, it is a mistake that we should avoid. Obviously, clearly for this program, it is a mistake. I mean, the loop is never going to be terminated. And that way, whatever the code I might want to write after this while loop, they will never be executed, isn't it? So to solve this problem, one solution is that, obviously in each iteration, we want to change the value of I by some amount so that at some point of time, this condition becomes false and the control goes out of the loop. I mean, I stop this program, say, and again, if I run, this time, since I changed the value of I, I'm changing the value of I in each iteration inside the body of the loop. At some point of time, I is less than 4 will be a false condition because it is going up and up. It is starting from 0 and it is going up and up. And our checkpoint is at 4. So obviously, at some point of time, it will cross 4. And immediately after that, the loop will be stopped, isn't it? So that way we can actually make a loop, like, prevent a loop from being infinite. At this point, it seems like writing an infinite loop is like only an outcome of doing some mistakes in the program, right? Okay, let it be like that. We'll come to know, like, it is not a mistake always. Like sometimes intentionally you might want to write an infinite loop, and we'll come to that point. But before that, I guess up to this point things are clear. Now, since I said that infinite loops can be written using while loop as well as for loop, let me show you how you can actually write an infinite loop using for loop. Okay, let's begin. Say we know, like, for loops are actually iterators. Like it allows you to iterate over a collection of elements, right? Say for example, we have a list and we store only one element in the list. Say that element is the number 1. It could have been anything, okay? So it could have been easily 10, no problem with that. But the point is, right now we have only one element in the list and we want to write an infinite loop using for loop, right? So how to do that? So for that, you'll be writing for it's, you know, right? For each element I in L, or we want to do something. We want to write here print hello. Hello. Okay, this is the right spelling, I guess. Hello. Hello. Now the point is, if I execute this program, this is not an infinite loop here, just because of the nature of this for keyword, the way it works. How it works, it just goes over this collection that you specified. This I will be set to initially point to the first element in the list or the collection, and then it will execute the body, and again it will go back and will check if there is any more element in the collection. If it is there, then it will go to that element, and then again it will execute the body. So I have a video on for loop. Like, if you are not very clear with for loops, then you can go back and you can check that video. But for the time being, I think things are very much clear. All these details you'll get in the description section. Okay, like the video link to the videos or playlist and everything. But for the time being, I think things are clear. So if I now execute the program, if you see the output, it will make sense actually. Okay. So now see, list is equal to 10. I in L, I'm printing hello. Instead of printing hello, I could have easily write here, say for example, I directly. So I will be, since I will be pointing to the list elements one by one. So whatever the elements are there in the list, it will print all those elements. So certainly this is not an infinite loop. If I store here, say another number 20, easily it will display us 10 and 20 on the screen as an output, not an infinite loop. Then how we can convert this for loop to an infinite loop? We know one thing. We know that, like, after every iteration, that is after executing the body of the loop, every time it goes back and it checks if there is any more element there in the collection. If it is, then immediately I'll be pointing to the next element and the next element. So if somehow we can make sure that always there will be an element next, then the loop will become an infinite loop. And how do we do that? So we can do a small trick here. We can write, like, say L.append, and then we just can store any number there. Right now our main concern is not the actual number. Only thing is that we just want to push one element at a time, so that the collection never goes out of elements. Okay, so I write here, say for example 0. So now if I execute this program, you'll see something like this. See, it's going on printing 0 0 0 0 0 0 0 0. Why is it so? Because you see, after printing I, that is whatever it is, this element, initially it will be printing 10, then it will print 20. Immediately after printing a number, it is actually appending a new 0 at the end of the list. So the list is like, every time it comes inside the body and it goes out of the body, immediately a new element appears there. So again, the loop variable goes to the next element, it executes the body, and then when it goes back, by that time another element sits there. So that way the collection is actually sort of infinite collections, right? Always it will have the next element like that. So that way this is an infinite loop. Like, see here, this loop is still getting executed again and again and again and again. So this is how you can write an infinite loop using for. But for most of the practical problems, like if we need ever an infinite loop, we'll be actually using this while we'll be using while loop to create an infinite loop, rather a for loop. Although it seems like both of them are doing the same thing, the point is this infinite for loop is occupying more and more space, because you see here, this list is actually a container in the RAM, and what we're doing is we are actually going on increasing the size of the container. Every time we are putting a new element in the container, means it is occupying more and more and more space in the RAM. So that way, this is not a right approach to write an infinite loop. Just for the sake of an example, I showed you, like, if you ever have to write an infinite loop using for, this is one way of doing the thing. But for all these practical uses, like wherever we need an infinite loop to solve some problems, we'll be using this while notation of an infinite loop. Clear about infinite loops? Like, these are loops that goes forever, right? But still, I didn't say you the actual use case. I have not yet said you any proper use case of an infinite loop. I just showed you some examples of infinite loop. Okay, this word is like prominently wrong. I mean, clearly wrong. Okay, anyhow, now let's see, before actually going to the actual use of an infinite loop, let's say how we can actually break an infinite loop. I said you that we'll be learning about the concept of a break statement also. So let's first learn about it. It's a very simple, straightforward concept. You will learn it in 1 second, so don't worry. Let me write some code here. You will understand it. Now, what does this break do is actually it breaks the now it takes it takes the control out of a loop, out of the enclosing loop. What I mean by this, actually, let's see. Let's write a fresh loop here. Say for example, or what I can, okay, let's write a fresh loop here. We'll be doing while loop. So let's initialize the variable I equal to, say, starting with 0, and then we'll be writing while I is less than, say, one number I chosen randomly, I is less than 100, and then I'm writing here print and say for example hello. Okay, and then what I do is I increase the value of I by 1. I is equal to I plus 1. And that's all. If I now execute this program, then you'll be right, like it will be printing hello 100 numbers of time on the screen. But what I can do is I can write here something like break. Now, as I said, break statement, whenever it is executed by in a computer, it takes the control out of the loop immediately. What I mean by this, okay, let me show you this diagram here. It is important. You will be using breaks quite frequently, actually. So now you can think of like this is a loop. Like diagrammatically, if I have to represent a loop, it will look something like this. So a loop means always there is a condition. Somehow there will be a condition, and when this is a condition, actually condition, and whenever this condition is true, the body of the loop will be executed. This is the body of the loop. By this time, I guess if people are familiar with these terms, and once the body of the loop is executed, it will go back and it will check the condition one more time. And if the condition is again true, then what will happen is this body will be executed one more time. So somehow if you can make this condition always true, that becomes an infinite loop. Now at some point of time, or most of the times, or whenever we write a loop, there will be a certain point where this condition will be false, and when the condition becomes false, we say the control goes out of the loop. Now see here, if the condition becomes false, then the control goes out of the loop. It means whatever the statements you write here after the loop, those statements will be executed. As long as the control will come from top to bottom. It always flows from top to bottom. So whatever the statements you wrote before the loop, they will be executed, and at some point of time the control reaches this loop, and it will check the condition. As long as the condition is true, the loop will be executed again and again and again and again. That's why this is a loop. And at some point of time, if the condition becomes false, then the control goes out of the loop. If these things are clear, now we are ready to introduce the break statement. Now see, right now, if you don't know anything about break, then right now there is only one way out of a loop, and that way is due to the failure of this condition. As soon as this condition becomes false, then only the control will come out of the loop. If this condition never becomes false, the control will always remain inside the loop itself. But suppose for some reason we might want to transfer the control or throw the control from inside the body itself. We can do it, and we can do it using a break statement. Okay, using a break statement. What does this break do is, say for example, you write here a break statement, and when suppose at some point of time this condition is true, it is executing the body, and it reaches here this break statement. As soon as it executes the break statement, what will happen is this loop will be broken down, and immediately the control of execution will reach this point. Directly out of the loop it will go. It means what? After execution of a break, it is never going to go back and check the condition. No matter whether the condition was true or false when it obviously it will be true, right? So no matter whether the condition is going to be true or false after the execution of this body, it is now not worried about that thing. Immediately, as soon as it sees a break, it means that it is an instruction like to the computer sort of to take the control out of the loop. No matter whatever it was doing that point of time, just stop everything there and just go out of the loop and execute the statement which is just after the loop. So break allows you to take the control out of a loop. It's another way of taking the control out of a loop, actually. You got the point? That is as straightforward as that. Now we'll write some programs, and then we'll see, okay, that is what it means. But right now, for the time being, what you should remember that break takes the control out of a loop immediately. Break takes the control out of a loop immediately. Got it? Okay. Now let's go back to our coding and see what output it generates if I write here simply a break. Okay. Let's see what will be the output. only once hello. See, I equal to 0, 0 less than 102, print hello, and then increasing the value of I by 1. So I was 0, 0 plus 1 is 1. And then we are executing this break statement, right? So we know, like, as soon as this break is executed, the loop will be terminated. Immediately the controller will reach here. Whatever the statement is there after this while loop, that would have been, that will be executed actually. Since there is nothing here, nothing is coming. Say for example, I write here print, and I write here, say, after the loop. Now let me do one thing here, just to see the output properly. Let me write here a small number, say for example 4, and say, let me put this thing in comment, this break. See, whenever you write a hash in front of a Python statement, it means that is a comment line. It means that is Python interpreter is not going to see that thing or that line as a part of the code. It is as if that line is not there. Got it? Okay. So it is same as, like, you can think of, like, I have deleted that break statement from there. Okay, now let's execute this program and see the output first. I is less than 4. So obviously, as you can guess, this program will print hello, 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 hello 4 times because of this while loop's initial value of the counter is 0 up to 3. The value of I, the valid value of I to get into the loop will be 3. So 0, 1, 2, 3. 4 times will display hello, and once it is done, once the loop is over, it will be printing you after the loop. It means once the loop is over, always it will print you after the loop on the screen. Now let's bring that break statement once again here. What will happen if I execute this program? I is less than 4, no matter what this value, say initially obviously it is 0, 0 less than 4 is true, print hello, 0 plus 1 will be stored back in I, that is I is right now 1, and then break. Now, once this break is executed, as we know, it will take the control out of the loop. So the controller will reach this point, that is print after the loop. It means, see here, break is never going to, as soon as you execute this break, the controller is not going to go to the condition to check it one more time. The loop is sort of terminated. You are sort of jumping, you're transferring the control, you're throwing the control out of the from inside the loop to out of the loop. Okay, so as a result, if I now execute this program, you'll be seeing, like, okay, hello, and after the loop because of the execution of this break statement. Got it? Now here it is just an example I'm showing you. It is like, it is not doing anything meaningful. I mean, if, say, you might be thinking, like, say, if you wanted the loop to be executed only once, you could have done it very easily, just simply by writing here 1 and getting rid of this break statement. It is true that we could have managed using without using break. Even, I mean, you can think of a way of doing the thing without using break ever. Got it? I mean, break is sort of just a convenient way of doing the thing, or it is sort of a shortcut way of doing the thing. Without break also you can manage all the situations, no problem with that. But break allows you to do something in a straightforward way, sort of. Okay. Now, since you people have now understood what is break, or at least what this break does, now let's see some more example. I mean, I could have written here break inside a condition. So for example, if I write here if I is equal to 3, as soon as this value is equal to 3, I want to execute break. That is, I don't want to execute break I don't want my program to execute break blindly. I just want to check if it has reached that value 3, then only I want to execute the break statement. And you are right, you could have get rid of these 2 lines of code and directly you could have written there a 3. It would have worked exactly the same way. But we are learning a new thing there. Okay, I mean, sometimes it becomes quite useful actually. Okay, anyhow, if I now execute this program, although this I less than 10, I mean, this allows to iterate the loop 10 times since we are increasing the value of I by 1 in each iteration, but still, due to this break statement, it will print hello only 3 times. Clear? So that is how we use a break statement. Break allows you to take the control out of the loop, out of the enclosing loop. Clear? Okay. Now we have learned, like, what is an infinite loop and what is a break. Now we can use both of them in a combined way. Now let's see how we do that. Say for example, I write an infinite loop here. I write here, see, this is another way of writing this infinite loop. So for example, I write here I is equal to initial is 0 and then I can write here while, point is this condition should always be true. So since we always wanted to true there, directly you can write the boolean value true there, right? No need to check any condition, always it is true, something like that. And then suppose I print here the value of I. And suppose we want to print the values of I from 0 to 10, but without using any condition here. Okay, so that's a restriction sort of. So what we can do is we can write here, if the value of I is less than or equal to 10, then what we want to do is we want to execute a break statement. Otherwise things are okay. Otherwise, like say things are okay. I is equal to I plus 1. If it is not less than or equal to 10, then what we want to do is we want to increase the value of I, and we want the loop to be executed one more time. Now let's see what will be the output of this program. You see here, okay, this program is showing you a 0. Why is it so? Print I, if I is less than equal to 10, break. So obviously 0 is less than equal to 10, it will break. But what I can do is I can write here, if the value of I goes beyond 10, then we want to stop. So if I greater than 10, then you stop. Otherwise, just repeat the process. So it will be printing here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Why is it printing you 11? Yes. Now see, as soon as at some point of time 10 is greater than 10, that will be a false condition. So it will skip this break, and then it will make it 11. 11 will be printed, and then it will become a true condition. 11 greater than 10, it will be false condition. It will be true condition, I'm sorry. It will be true condition, and it will execute this break. So if you don't want that 11, so what you can do is you can write just here greater than or equal to 10. You just want to stop the process there. Got it? So most probably now people have seen, like, this is an infinite loop I wrote, and I show you a way that even if the loop is infinite, there is a way actually that you can get out of this infinite loop just by writing some proper code there. And obviously, if it is the case, then you have to make use of this break statement. Clear? Okay, now let's go back to our point, like where I told you that I'll be showing you a simple game. That shows you the importance of infinite loop. Still here, it is not important, right? I mean, if I wanted to print the numbers from 0 to 10, I could have easily written and I equal to 0, I is less than equal to 10, or 10, whatever, print I equal to I plus 1. This thing is, not needed. They are not mandatory sort of, right? There are other ways of doing the same thing. Got it? Okay, let's now see the real use case of an infinite loop, where it might be useful. Okay, let's now talk about the game that I initially told you about, right? Now, what is the game? Now see, we'll be playing the game between the computer and human beings, a user. It's a me or not user, human here. Okay, now what the computer will do is it will first guess a number. The computer will guess a number within any range, within a specified range, within a known range that is known to the user also. Say, let's assume, just for this example, maybe the number is within the range of 0 to 10. What the computer does is it just guess, and it just makes a guess about these numbers 0 to 10. It randomly, you don't know, as a user, you don't know what number the computer has guessed. Okay, so within the range, anything it could be. This is this computer number. Okay, it has made a guess, and say for example that number is 5, but it will not tell you the number. The computer is not going to tell you the number. As a user, what you have to do is your guess you have to enter your guess, and enter your guess. Okay, and then you will be entering here a number. You also know, like, in what range you have to enter that number, and say that is 0 to 10. So you will also be entering a number. So if the number that you entered is not same as the number the computer predicted, then what we want is we want to repeat this same process once again. That is, again the computer will choose another number within the range of 0 to 10, maybe this time 1, and then again it will ask the user to enter a number. The user will again enter a number, and say for example this time he or she enters 9. This time also it is not a match. It is not a match in the sense the number that the computer predicted is not same as the number the user entered. So if it is the case, then yes, we know, like, we have to repeat the same process, and we have to repeat this process again and again and again until and unless both this computer and the user comes to a conclusion. It means, say for example, at some point the computer says, okay, the computer, it doesn't say, but it predicts or it guesses a number, say that is 9, and user also at the same time entered the number 9. This time both of them are a match. So say it says, okay, now you win the game, or you own the game. Okay, So that's the game that we are going to develop. Now see here, an infinite loop is quite, it is important. You cannot like avoid the need of an infinite loop here, because we don't know exactly at what point, as a programmer, at what point we have to terminate the loop. Maybe the loop is going to be executed for say 10 times, maybe only one time itself. In the first guess itself, suppose the user is very lucky, he says here itself 5, so the loop should have been terminated in the first iteration itself. Okay, or sometimes the user is very unlucky, and then after 100 iteration, he or she is not getting a match. Right? So we don't know exactly when these two things are going to be a match, right? And as soon as that happens, we want to terminate the loop, and we know how to do that, right? Using a break statement. Since we now know how to write an infinite loop, how to go out from inside a loop, how to break a loop, and so we are sort of ready to develop this small game. Only one thing is a problem here, and the problem is, how the computer predicts the number. How the computer can think of a number. And that's where the concept of random numbers come. It is quite an common, useful, frequently used concepts in computer science, and that is the concept of random numbers. And in any programming language, you will usually come up with some packages or inbuilt or pre-written code that actually generates a random number. Okay, so we'll be seeing like one inbuilt library in Python, inbuilt module, you can say, random module, with the help of which we'll be able to generate random numbers in Python if needed. See, this video is not about random numbers. Okay, I'll be talking about random numbers in more details, since it's a very important concept in like scientific computing. More specifically, if you want to do some scientific computation, then random numbers plays an important role. You people know that, right? Yes. So for that reason, I'll be like covering these random numbers in another video. But for the time being, I'll be telling you small things. One or two small functions which you can use. Actually, there is no, like, you should not consider it like, okay, that's, even if I don't know it, it will work, right? But no harm, right? These are small things, you can remember it actually. Okay, let's begin now with this random part, right? Because we know already, see here, our goal is to develop this game. We already know how to develop and how to write an infinite loop, how to, stop an infinite loop. Only thing that we need to know is now how we can make the computer predict a number within a given range. It's quite straightforward if you know this random module. Okay, let's let's learn this random module. So for that, you have to do is, yes, if you want to make use of some existing code, then right? You have to make use of this import statement. Import statement as if like you're bringing in some existing code with your code, okay? So for that reason, so I'll be importing this random module, random, random. I'm importing random, that's all. Okay, this is an existing pre-written, you can think of it as a pre-written Python file there. And there are some functions written inside that file, so you want to make use of those functions. Okay, so that's the meaning of importing random module. And from here, what we can do, I'll be talking about two functions. One function is like, if you want to get a random number within a range of 0 to 1, then you can get it very easily. Say for example, I is equal to I is a variable that I'm declaring, and then on this random module, there is a function called random. The name of the function is same as the name of the module, and that function returns you, it returns you a number within the range of 0 to 1. It could be anything like 0.1, 0.5, 0.9562, or whatever. Let's see. Like if I write it in this way and I print this number I on the screen, you'll be seeing that every time I execute this program, you will see a different number within the range of 0 to 1. Say this time it is showing you the number, say 0.0007. Again, if I execute this program, you'll be seeing the number is 0.87. If I execute this one more time, it will be showing you another number, say 0.34. Got it? So this function, as you can see, it is returning you every time you execute. You don't know exactly what number it is going to return you, and that's why it's a random number sort of. Although I say you don't know, but these are pseudo random numbers. Okay, they are not perfectly random, but for the time being, for our case, we can consider them as random numbers. Now you have seen like what this random function is doing, but here the problem is that these numbers are within the range of 0 to 1. But what we want is, we want some numbers, some integer numbers, not some floating point numbers. So if it is the case, then you can make use of something like rand integer. Okay, say for example, there is another variable I have declared j, and on this random module, like inside this random module, there is a function called rand integer, rand, that is for random, int, it is for integer. And when you say rand integer, you do see you have to specify two things, like what is the starting point, what is the ending point, like within which range you want that integer to be. I want that integer to be within the range of, say for example, 0 to 4, and let's print this j and see the output here. Okay, so within the range of 0 to 4, it will just give me some number. Say first time if I execute it, it is giving me a 0. Next time if I execute it, it is giving me a 1. They will not be 0, 1, 2, 3, 4. Okay, so this time it is giving me a 4, and next time it is giving me a 3. You see here, including 0 and 4, it can give you anything. That is from 0. See, when I write rand integer 0, 4, it means 0, 0, 1, 2, 3, and 4. 5 possible outcomes are there. Okay, so out of those 5 numbers, any number it can give me. Got it? Okay, now what is our point? I mean, now we know, right? I mean, I can ask the computer to make a guess within the range of 0 to 10. You make a guess of, you can make a guess of any integer number. So the computer can do that, right? So we now know, like this part also, like how we can make the computer to make a guess. So if we know all these different parts, right? Now it is time to put all of them together and develop the game. So let's do it. So how do we do that? So, okay, now let me write here another code block here, another block of code here. So what we want is, okay, I'll be importing this random module. I already have imported it here, so it is not needed here, but still, suppose we want to write everything from scratch again. So import random, and then what we want is, the first thing is that we want the computer to predict a number. So for that reason, what we'll do is we'll write here, say computer's number is equal to random within the range of, random.rand integer, int, within the range of, say 0 to 10. It could be anything, 0 or 10 or 5 or 6 or 9 or whatever, but within the range of 0 to 10 and integer numbers. It will not generate 0 0.23 or something. Okay, if it is the number, then we want the user also to enter some number. So let's get the number. User's number is equal to input. We know, right, how to take input from user. So input function you have to make use of. And then here we'll be displaying, like, say, enter your guess. Enter your guess. And what we want to do is, okay, once the user enters the number and the computer also has predicted its number, it's time to now do a comparison. So we'll be doing, like, if whatever the number the user has entered is same as whatever the number the user has, the computer has predicted. So I said it in the reverse order. That is, if the predicted number by the computer is same as the entered number by the user, then what we want to do is, then what we want to do is, yes, we want to display here print win. Say for example, you own. Say you own. But if it is not the case, else part, else, we want to, like, display the user, like, please try again. So try again. Now it might seem like, okay, this program is good, but what will happen? Now, this program will be executed only for once, right? You can see here, there is no loops here, right? So let's execute this program and see the output here. So it has guessed this number. The computer has actually predicted his number, and now it is asking the user to enter the number. So I enter a number here, say within a range of 0 to 10. Say I entered, say 2. Okay, I press enter. So 2 is not, most probably is not equal to the number the computer has predicted. So for that reason, it is showing me try again. But is it really the case? I don't know what is the CN, right? But for the time being, let's ask the computer, okay, we are learning the process, so you please tell us your number also. So we will be displaying here print the current number, whatever it is. We just want to make sure that everything is fine. See, the computer has predicted the number, and we ask the computer, now you predict and also you tell us the number. It has told us the number is 1. If I make a guess of 1 now, it should work, right? Now, say, I mean, it should work in the sense like computer's number will be same as my number, so it should display me you own. But it is not going to do that. It is still saying me try again. Now, if I ask you what is the reason, you know, if you have seen my, like, how to take input from computer, I mean, in Python program, that part of the video, then you'll be knowing actually that these input that the user enters, they are in the form of string. They're not in the form of numbers. Here we're comparing numbers with strings. So that's a problem. So we have to convert one to the other format. Like we might convert this un, that is the string, to a number, or what we can do is you can convert the cn to a string. Both way it will work. Based on the situation, certainly. Say for example that I take the easiest way, I convert the number cn to a string, that is, if it is 1, then it will be one string version. So that time it will work actually. You see here, now the computer has predicted 9. So if I write here a 9, then what the computer will compare in this if statement will compare is it will first convert that number 9 to a string, and then it will compare that string 9 with string 9. So obviously it will be maths. I'll be showing me you own. More or less things are in place, but there is one problem here. A problem is that it goes only for once. Right? I mean, I can write here now, what I can do is I can put everything inside a loop so that it goes forever. So what I'll be doing is I'll be selecting everything. I'll put some indent here, and then here I'll be writing a while loop. Say while I just want this loop to go forever. It's an infinite loop that I want to write. Okay, so while true will it will satisfy the need, right? So while true, this thing is going to be, the loop will be executed again and again, and in each iteration it will predict a number. It will ask the user to guess the number, and it will either display on or loss, right? So let's execute this program and check the output first. So we fooled the computer, right? I mean, you predict the number, you also tell us the number. So that time making a guess is not a difficult. I know the computer has predicted 9, so I'm writing here 9 equal to 9 is true. It said that I own, but still again it is just repeating the process. But what we want is that as soon as we win, we want to stop the process, but if we lose, we have to continue the process. Okay, so the process should be continued only when we lose, but we don't want to continue if we win. So it means what? When we win, we want to actually stop the process there itself. So what we can do is we can write here a break statement. See here, this break will be executed only when the prediction, the computer's prediction is same as the user's guess, right? So only that time it will show me you own, and only that time this break will be executed. And it means as soon as the user user correctly guesses the computer's prediction, it will stop the process there. Got it? Okay, let's now re-execute this program and check the output. Okay, I run the program one more time and see. Now here is this one we don't want the computer to display us, but we are doing testing, so we know. Let's enter here a number which is not equal to the prediction. The prediction was 1, and we have entered the number as 2 intentionally, so that, okay, let's see what happens. It says try again, but while saying it's try, you see here this try again is coming from here, and once it is over, it is going back to this this condition which is true always. It is predicting another number. It is displaying that number which is 9 on the screen, and again it is asking the user to enter your guess. Enter your guess is coming here. I can enter any number here. I'm entering here 9, say. So what happens here? See, as soon as I enter 9, it says, okay, 9 is equal to 9. You own. And since this break is there, it stops the process there. It means the loop, although the loop was infinite, but now the loop is over. See here, it's no longer like, executing the program. You got the point? So that's how. See here, without that infinite loop, there is no other way. Like how you can always, because see here, when we want to execute this break, only when these two conditions are true. And one part of this condition is on the hand of the user, right? I mean, if the user always makes the wrong prediction, always it will be asking the user again and again, like you won. Sorry, you lost, so try again. Let's like make this game more fair, right? Right now it is not fair because the computer is predicting and at the same time it's showing you, okay, I have predicted 9. Now it is your time to guess. Obviously, the user knows, like, okay, the computer has predicted 9, so I also have to write a 9 there. So let's hide this thing and let me use like a comment here, okay, so that people get used to using comments. Like hash, if you write, as I said, it will not be part of the program. It will be like for human only. Okay, so it is as if I have deleted this particular line from this program. Now let's play this game. It will be fun. enter your guess. This time you don't have any like reference. What should I enter? Yes, we suppose both of us agree, the computer and us, like, okay, the number should be within the range of 0 to 10. So I'm making a guess. Like, let me see how lucky I am. I'm entering 8. Oh, no, I'm not lucky. I have entered 8. The number was something else, maybe, and it is not a match. So it is saying try again. So I entered 1, say, and let's see. You won. I was lucky in only in 2 go. But you see, this might not happen actually. If you write this program by yourself and if you play, you'll see that sometimes you'll be like, you'll go again and again and again. You'll feel like there is some mistake in the program itself. Like, how come I didn't get a match till now? Let's try it again. Say I have entered 3. I might be very lucky in the first go itself. Again, I have entered, say, 2. Try again. Entered 9, 8. Say it is saying try again. Maybe 9. You won. I won like in my 4th go or something. Again, if I execute the program, it might happen. I might win in 1 go. I might win in 4 go, or maybe in 10th go, or maybe in 100 go. Right? But that number is not fixed. That is the main point. So for example, if I enter here 2, try again, enter here 8, say, try again, maybe 9. I can just choose any number. Try again 3, try again maybe 1, try again 5, try again 8, try again 3. I mean, that way, you see, this time I'm not lucky anymore. I enter 4, try again 4. What I can do is I can stick with 4, because I know like 1 out of 10 chances there that there will be a 4. So if I accumulate all of them, I might, like, you know, at some point of time, obviously it has to show 4, right? So I write here another 4. Every time it asks me, like, you know, it is as if you are going for an multiple choice questions where you don't know anything about the subjects, but you want to still score some numbers. All these options have, suppose, 4 choices. Then you can stick with 1. You see here, I own. You can stick with only 1 option. Like, say, always I'll be writing the answer as A. I'll always put that circle on A. So 25%. Suppose there are only 4 options for each of these questions. 25% chances are there that 25% of your answers might be true, actually, and then probabilistically. Obviously, it will not be exactly 25%. It might be 0% also. Suppose you have chosen A, and there is not even a single question whose right answer is A. The probability is very less, but yes, it might happen. Or it might happen that all the questions answers are A. It is also very unlikely. You got the point? Yes. Now see, that's how we can develop a game. See here, I had to try many a times, like, you know, maybe more than 10 times this time to get a right prediction. So that is the importance of an infinite loop. You might, based on your need, the problem that you're trying to solve, it might happen that you actually need an infinite loop, and, you know, you want to, whenever you want to work with infinite loop, it is very common that you have to make use of this break statement, obviously, at some point of time, because at some point of time, although you are making use of an infinite loop, at some point of time, obviously, you want to go out of the loop, right? So for that case, break is your tool. Okay, guys, then that much only. I guess you people have learned the concept here, infinite loop, break statement, and like how we can, you know, generate random numbers very easily with the help of this random module and some functions like randint or random function here. Okay, so hope you people have learned something from this video. You got some value out of this video, and if you like this video, please press the like button, subscribe to the channel, and share the video with your friends. Okay, guys, then that much only in this part of the video. See you guys with some new content in the next video. Till then, have a nice day.